Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to look at a concept in chemistry. Of course, that is the concept pertaining to the molecular formula. I'm going to use a different way. So for that, we have a molecular formula, and one of our videos that we have already done, of course, I'm going to put a link in the description box. I've talked about the concept of empirical formula. And we're going to differentiate between the two. Now we see that the empirical formula is the simplest formula of a given substance, and it gives the elements present in their simplest form. Now for this one, of course, it represents the simplest form of a substance, or the simplest formula of a substance. And this basically gives the elements present in the simplest form. So basically, empirical formula, as we said, is the simplest. Now the definition for the molecular formula, just to differentiate the two aspects of the formula. Of course, both of them are formulas, but the difference is the molecular and empirical formula. So in this case, we're going to see that for molecular formula, it shows the actual number of each element in a compound, whereby the subscripts, just like the empirical formula, are used to denote the number of each particular element. Now for molecular formula is a derivative. This is basically a derivative of the empirical formula, in a sense that there's a relationship which I'm just going to use to denote that, whereby the molecular formula can be represented as n empirical formula, whereby represent n number, which is a whole number, of course. And we're going to see that this particular concept is going to be applied in trying to find out how we can be able to represent the molecular formula of different compounds. So in this sense, therefore, I can say that n, which is that specific number, is equivalent to the molecular formula divided by the empirical formula. And n, as we have defined it, we're going to see it from our illustration, that is a number of each element in a compound, or the ratio between the molecular formula and the empirical formula mass. So this, so of course, as we talked about the percentages, it's going to represent the masses of these two specific aspects of a compound. So in this case, I'm going to use just a sample question in trying to differentiate between the two aspects, that is the molecular and the empirical formula, and try to show the relationship that exists between the two, in that the molecular formula is a derivative of the empirical formula. So I'm going to write the question on the board. So the problem set states that a combustion analysis gives the following mass percentages. For hydrogen, it's 9.15%, carbon, it is 54.53%, and oxygen is 36.32%. Now we're going to use the approach that we had already employed for the empirical formula, and that is trying to find out the ratios of the masses of the three compounds that are making up this particular compound, the three elements that are making up this particular compound. So in this case here, we are going to have the element, and then next we are going to have the masses representing those elements. So for that case, we are going to find the ratio between the mass and the relative atomic mass of that element, in order for it to give us the ratios of those elements. So if it's making up 54.53% for carbon, the relative atomic mass for carbon is 12, and then we have 9.15 for hydrogen, which has an atomic mass of 1, and then we have 36.32 for oxygen, which has mass of 16. So this one will give us more ratios of this is 4.544, and then this is going to give us 9.15, then the last is going to give us 2.27. So the simplest or the smallest of all these mole ratios is this one. So we're going to divide by 2.27, 2.27, 2.27, and this is eventually going to give us the ratios of 2, 4, and 1. So this is the empirical formula that we have obtained for the mole ratios, as we are done for the empirical formula from our previous video. So this representative or the simplest formula for this compound is going to be C2H4 and O. But as we said, we can obtain a molecular formula from the empirical. This is the empirical formula by multiplying it by N, whereby N is the number, of course, of those molecules in that particular set. So we shall have the total of the masses of these elements times the relative formula mass of that compound. Now in this case, from determining the molecular formula, there's a condition here. We have been given that the formula mass for this compound was 132.16. So this is a condition that I'll just overlook, but it's essential for us now that we need to use it. So when we have got the relationship for this empirical and molecular formula, so this and the empirical, and then the product of this and this gives us a the molecular formula. So therefore, given that this formula is 132.16, bearing in mind that these ones represent the mass ratios as we have done from here, therefore we're going to solve for N by doing a substitution for this different set of elements that are making up the empirical formula. So we shall have N. For carbon, the relative atomic mass is 12, so we have 2 carbon atoms. Therefore, we should have 24 plus hydrogen is 1 times 4 is 4. Oxygen is 16. So this is going to give us 44. N is equals 132.16. N is going to give us a value of 3. So therefore, for us to get the molecular formula from this particular set of empirical formula and the number N, we're going to do a substitution for N and then write this is 3 C2H4 and then O. So therefore this one, the product of this gives us the molecular formula, which we're going to get is C6H12 and O3. So this one represents the molecular formula for this compound that was undergoing combustion in this analysis, which can be represented as such. So this basically is the procedure that we're going to use in obtaining the molecular formula of different compounds, bearing in mind that there is a relationship between the empirical formula and the molecular formula that we have listed, and using that relationship in order to find the different ratios which are going to have a relationship with the total formula mass that's of course there. So this is the procedure actually that we're going to solve for other compounds of the same kind, so that they can assist us to find and solve problems of this nature in our discussion. So for that case, that is it for today. Thank you guys. Bye. God bless you.